and welcome to the IntelligentAg Spray Quality Study Area. Before we get to the plots, I wanted to walk through some of the problems that occur on a typical sprayer today. Now, we're standing in front of a really modern sprayer, one of the best you can buy on the market today, and a Rogator 1100C. This is a 2020 model. It's basically outfitted with every feature you can get. Liquid logic, recirculating boom, clean out system, auto fold, unfold. It's got four-wheel steering. You can crab walk it. You can turn on a dime. It's got electronic valves on all the spray nozzles, so you have really good section control and spray nozzle control. With all those features, for all that money, you still can't tell what's coming out of every single nozzle tip. And that's what we want to show you today, is how devilishly difficult it is to see flow problems as an operator, or just in general, even when you're inspecting a boom, how difficult it is to see those flow problems, and they're actually worse than you probably think they are. So we're going to walk through some examples and kind of illustrate those, and then we'll show you the impacts in the field with our plot trials. Okay, so the first example on a boom we're going to check out is basically what good looks like. So we want to see what all the nozzles look like when they're doing what we want them to be doing. And so you can see in this first part of the boom, we've got all these nozzles are in good working order. They're outputting about the same amount each. Our app is showing good flow on each of them. So this is what really good looks like. That's what we want to achieve across the entire boom. Okay, and now going on to the second example. Here we're still in the same section of the boom, but we've introduced a nozzle that has a problem. And I want to just take a minute for you to scan all of the nozzles that are on at this time and see if you can pick it out of the crowd. There's one nozzle that has limited flow. It's not a full blockage, it's not fully off, but it has some kind of a flow problem. Did you catch it yet? Okay, so it's actually this one. You can see it here on our app, and you can see it up. This one actually has a little bit of a streakiness. This is a pretty common issue that can happen in sprayers of all kinds, where a little piece of sediment or some kind of a particle gets into the stream, and because these orifices on these nozzles are so small, they can get jammed in there pretty good. And even a small little piece of sand or little sediment that got kicked up in the pumping process can get into those nozzles and cause a problem. And so now you see you've got some streakiness going on, and the streakiness is interesting because you get lower flow overall, but you also have points in the field that are going to be zero in that stream. And so that causes multiple issues. You get less rate in some areas, but also zero rate in the others. So that's a streaky nozzle. And just to prove to you that we're not lying about our data, we're going to show you these visual catch cans, basically, that have a clear container we put up over the nozzle, and it'll catch all that water, and we can show you in real time, just so you can verify what we're saying when we're saying that there's significant flow problems or whatever throughout the boom. And again, here's a visual check to show you the difference between a good nozzle and a streaky nozzle like this one. Okay, now in this third example, we have a section of nozzles where we have simulated a low flow nozzle and a nozzle that has higher than normal flow. Now, why would higher flow happen? This can happen because maybe you've been using this nozzle for too long and that orifice has started to wear out, so the hole is actually getting bigger. And so because of that, at the same pressure, it's going to output more flow than its neighboring nozzles. It also could be that, by golly, I forgot to change the nozzle tip, and now I got extra flow coming out of this one because I put the wrong tip on there. Whatever the reason, we've got more flow coming out of this nozzle. Both the spray patterns are unaffected. On the low flow, that could have been for a number of reasons as well. Maybe I have the wrong spray tip, but I also might have a pre-nozzle filter that's plugged up with some gunky material or whatever. That could be causing that low flow. So let's scan the spray. Can you see which one's low, and can you see which one is high? Now, some of you might be able to see the low flow nozzle. And that's really good. You've got a well-trained eye. Put yourself in that operator's cab. Now, we got the luxury of being right behind this sprayer in good conditions. But put yourself in the cab of that sprayer and ask yourself if you would have seen that problem. It's really hard to even see. This particular one is very low flow in that 25-20% range of what I was expecting to get. Now the other one, I would venture to guess most of you couldn't see because it's a higher flow and roughly around 40% more flow than I was anticipating, and you could notice how difficult that one was to see. And again, we'll do the visual check here with the containers to show you the differences. And you can see how fast the one on the right is filling up, and the one in the middle is the one that is good. That's what we want, and you can see how much less flow on the left we're getting. So again, this is one of those examples where you can't believe what you see. I would venture to guess that most of you could maybe see the reduced flow, but you probably didn't think it was as bad as it was. I mean, we're basically getting no product on that part of the field. Okay, now we're going to move to our fourth example, and we've actually switched nozzle tips for the last two examples here. What's very common in the industry today is a big emphasis on drift reduction, and so we've used drift reducing nozzles. What that means is the nozzle tip is going to output larger droplet sizes to help reduce the probability of drift. Bigger droplets don't move as much in the wind. That's a great thing for some of these chemicals. However, bigger droplet sizes don't produce as much of a mist, and so they're even harder flows to see for an operator. And so now with all these drift reducing technologies out there, now it's even harder to catch variations in flow. And on this boom, we have, as we started with the other nozzle tips, we have one of those streaky nozzles, and can you see where that one is? Maybe easier to see because we have some skips in the spray pattern in general, but still tough to pick up, especially if you're in that cab of the operator's seat. So you can see it was this one, and it has significantly less flow compared to what we were shooting for. You can see that on our application, and we'll show you the containers here that are showing the output of the nozzles as compared to normal. And now in our last example, we'll finish up with a low flow situation and a high flow and ask you to try to identify on these drift reducing nozzles which one is the low flow and which one is the high flow. And I'll give you a minute to scan through and see what you can see. And here we can see on our app that the fifth from the left is pointing out that we have a low flow situation, and 2 away from that is showing a high flow situation. Now I played a little trick on you because we actually have an additional nozzle way off to the right of this section that's higher flow. Now why would that be? In this particular machine, we have all these nozzles lined up on the machine, but you see this big fold point, and there's actually a skip in the nozzle spacing. And because of the way this machine folds up, they actually have to put the nozzle out in front of the boom as opposed to all the rest of them are behind the boom. And what happened was we were going through and switching all our nozzles because we were, switching chemical types, and we needed a different nozzle type. And guess what? We forgot that one on the front side. And so we may have sprayed in the case of a typical operator, moving fast, switching fields, switching chemicals, filling up, doing everything he's got to do. You're running through trying to switch nozzles and you accidentally forget to switch one, and this would be a very common one to forget to switch. Our app showed that immediately that we had a high flow situation. We saw that variance on the application, and now all of a sudden we have the tools necessary to be able to identify that situation immediately and go fix it before it becomes a big problem in the field. And again, we'll show you the flow rate differences between that low, the normal, and the high, just so you can see the amount of water we're talking about in that short time period. And that concludes our sprayer demonstrations of nozzle problems, and really trying to drive home the fact that it is really difficult to see flow problems. Seeing is believing when you get into the field and you see skips in the field of coverage and you see weeds. But when you're looking at your sprayer, you really can't believe what you see, because it's very difficult to see these flow variations. And I'll tell you, on every single sprayer we've been on, there's been several instances on those sprayers where there's some kind of flow problem. Might be high, might be low, but you don't know until you have something like Recon Spray Sense, and that's why we feel this product is so important.